Alright, so what I'd like to do now is explain why exactly is it that a sub r dot in the a sub x direction is equal to the sine of theta times the cosine of phi. I have here drawn the coordinate axes for the x, y, z plane. Here's y, here's z, and this is the angle, the elevation angle theta. And then right here, we're just going to put the angle phi. Okay. Now, if I'm looking, this vector here, r, just goes out from the origin here into space. Okay. Another way of thinking of it is basically like, what happens if this pen just points into space? Okay, like this. Now I've just drawn that situation of the pen pointing this direction on the paper here. This angle here is going to be theta. If I draw a horizontal line that goes directly from the z-axis, let's just draw it like this, to the point of the r vector, then this angle here is also going to be theta. All right. Now, I eventually want to get from this r vector here, blah, 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 this one, all the way to what shadow does this cast on the x-axis? Now, the way that I'm going to do this is first, I'm going to take my r vector and I'm going to drop it down into the plane. Okay? Dropping it down into the plane means get this dotted line down here. It's only in the x, y plane. Okay? That's going to give me, okay, well, I look here, this is, it's a unit vector, so it's the sine of theta. That's this sine of theta here. Okay? Because this is the opposite over the value r. Alright, now once I have this, let's just draw another vertical. I'm gonna put the camera here and then I'm gonna draw it just so the drawing looks a little bit quality. Alright. If this is the right angle here and this is, you know, now that we've projected this r vector into the plane, here's the angle phi, then this distance here is gonna be cosine of phi. Okay? How do I make this into x, y, z coordinates? I don't necessarily use the strict definitions. I use of x, y, and z as provided in the book. I use the trigonometric identities of sine and cosine. So sine is the opposite over the hypotenuse, and I just express those in terms of x, y, and z. So sine of theta is going to be equal to, okay, well, I just said that it's going to be the opposite over the hypotenuse. Well, the hypotenuse is the easy one to see because it's just r. All right, and r in the x, y, z coordinates is going to be given by x squared plus y squared plus z squared, the square root of all that. And then this projection just into the plane here is going to be, what? It's just in the xy plane, so that's going to make the distance going to be x squared plus y squared. Next thing we want to do is cosine of phi. The cosine of phi is just going to be, okay, well, it's going to be x over, it's the adjacent angle here, x, over I said adjacent angle, I meant adjacent side length. It's the adjacent side length over this thing, we call this thing the hypotenuse now. So this is going to be x over x squared plus y squared. Square root of all that. Alright, the original problem, we just substitute in these these definitions for sine theta and cosine of phi, and then we have this expression as well, which was, you know, a over r squared, and we'll just also substitute in that r is equal to x squared plus y squared plus z squared. So this is just some sort of example how specifically you do that.